Hi, I'm B, and welcome back to my channel. In this video, I will share the common welding defects and its remedies. Welding defects can be defined as weld surface irregularities, discontinuities, imperfections, or inconsistencies that occur in welded parts. Technically, a welding discontinuity is the lack of a mechanical, physical, or metallurgical harmony in the weld. This could be manifested in terms of varied porosity, incomplete fusion, or joint penetration, and unacceptable profiles. The following are the common welding defects. 1. Inclusions. 2. Lack of fusion. 3. Porosity. 4. Undercut. 5. Underfill. 6. Cracks. 7. Excess reinforcement and excess penetration. And 8. Over-roll overlap. 9. Spatter. Inclusion. Slag inclusions are non-metallic particles trapped in the weld metal or at the weld interface. Slag inclusions result from faulty welding technique, improper access to the joint, or both. Sharp notches in joint boundaries or between weld passes promote slag entrapment. The following techniques can be used to prevent slag inclusions. Use welding techniques to produce smooth weld beads and adequate inter-run fusion to avoid forming pockets. To trap the slag, use the correct current and travel speed to avoid undercutting the sidewall, which will make the slag difficult to remove. Lack of fusion. Lack of fusion in welding occurs when the weld metal fails to fuse with the sidewall or joint, or when two weld beads fail to completely join together. At its worst, it can produce serious crack-like defects, which reduce the load-carrying capacity of the joint. Solution. The usual solution for lack of fusion is to increase your mean current, improving your operating technique, or choose shielding gases that provide a more fluid weld pool. Make sure your joint or root are well prepared and not too narrow to weld evenly. Porosity is the presence of cavities in the weld metal caused by the freezing in of gas released from the weld pool as it solidifies. The porosity can take several forms: distributed surface breaking pores. Remedies for porosity. 1. Choose the suitable electrode and filler material. 2. Ensure proper cleaning of the base metal and prevent pollutants from entering the welding area. 3. Adjust the welding speed as it varies across different welding techniques. Undercutting. Undercutting is when the edge of a weld has an inverse U shape. This is a weakness in the weld that typically is caused by when the travel speed is too high. Remedies. 1. Use proper electrode angle. 2. Reduce the arc length. 3. Reduce the electrode's travel speed, but it also shouldn't be too slow. 4. Choose shielding gas with the correct composition for the material type you'll be welding. 5. Use of proper electrode angle with more heat directed towards thicker components. Underfill. Underfill is a groove weld condition in which the weld face or root surface is below the adjacent surface of the base metal. To avoid underfill and undercut, you must 1. Reduce your arc length and current. 2. Reduce the welding speed. 3. Ensure you have the correct electrode angle and size. 4. Using an optimal weaving technique, allowing enough dwell time at edges. Cracks. Cracks are the worst welding defect, since they can rapidly progress to larger ones, which inevitably leads to failure. Excess reinforcement and excess penetration. For fillets, it is excess weld metal above the specified fillet size, including throat thickness. Excess reinforcement or penetration can be caused by excessive current, too slow travel speeds, and incorrect joint fit-up. Overroll or overlap. This is weld metal at the toe of the weld that covers the parent metal surface but has not fused to it, generally caused by slow travel speed and wrong torch angle. Spatter. Weld spatter is formed by droplets of molten material that has been splashed or scattered during welding, leading to the formation of unsightly globules of material weld spatter can potentially causing burn injuries as the molten droplets travel through the air. Remedies for welding spatter is to lower the amperage setting oppositely. A voltage that's too low will also lead to the same result.
Thanks for watching.